So now I was going to check out the GPS unit and see if it's functioning. And thanks to doing its pinout in the same way as the XBee, or doing the XBee's pinout the same as the GPS unit, I can just pop out the XBee and put in the GPS unit. And my wires will be, the power wire will be in the right place, the ground wire, and the transmission and receiving lines. I still don't quite understand why you have a receiving line on the GPS. But I guess there's some reason why you'd send information back to it. This is a simple program I threw together to check the GPS out. It uses two objects: the conduit for viewport, so I can bring out the variables and see them in the viewport software, and GPS float, which pulls out the NEMA data from the serial stream of the GPS and parses it out to the various variables. It has two variables, lat1 and long1, which I think I named that way because long is a reserved word by the program, so I just called them both long1 and lat1 for longitude and latitude. The first part of the program just sets up the viewport so that the propeller will talk to it, these first three lines. The next line sets up the GPS. Now this object from the propeller object exchange uses two cogs for getting the GPS data and two cogs for floating point math. Floating point math is something that threw me at first when working with the microcontroller. I had programmed in some very old languages, but they were all PC based, so I never really had to worry about what was going on with numbers that dealt with decimal points. The propeller chip can only do integer math, and it just doesn't natively do decimal points. But some smart people have put together various solutions on the propeller object exchange that allows you to do floating point math. But it is cog extensive. Because of that, just getting the GPS data and using it is costing me 4 of the 8 cogs. So now we're at the part of the program that assigns the latitude and longitude to lat1 and long1. These are both methods from the GPS float object. And I'm not sure of the speed, but I think the GPS updates everything 5 times a second. So we'll hit F10, which will load this program onto the propeller chip. And then we'll pull up viewport. And we see the variables lat and long here. And that information is coming off of the GPS. The next step is to learn how to receive serial data. I've always relied on other programs for that, either the Parallax Serial Terminal or objects like the GPS float. So I've got to receive the data on the other XBee and parse it out into variables.